You and your rocket are going out for a trip to the galaxy. On your way, you find this very black object which is gobbling up stuff. This is a black hole. You don't want to go anywhere near this thing as it has such a strong g-force that like you and your rocket, it will stretch it and it will take it into its black nothingness. Nothing can escape it, not even light. Well, light cannot escape it, but it can orbit it. But how? First things first. How do objects even orbit objects? For this, we need to take a little diversion. Wonky space. Space is like a blanket. Drop a ball on the blanket and there will be a curve form on the blanket. The same thing happens with planets or any other matter in space. They bend or distort space. The greater the mass, the greater the bend of space. So, then how do things orbit each other? Let us take a look at this picture. In this picture, there is a star which is curving the space. Now, let us say you rolled a planet onto this space. The planet will tend to go in a straight line and then the curvature of the star will make it go in a circular path around the star. The planet will be in orbit. To put things into orbit, you also need the right amount of force. Let us see this experiment first explained by Newton. Imagine if you had a cannon that could shoot a cannonball far away. The ball would fly down and then crash into the earth. If you shoot the cannonball harder, it would fly further before slamming into the ground. And if you shoot the cannonball hard enough, and if you ignore air resistance, it would travel all the way around the earth. The cannonball would be in orbit. It's falling towards earth, but the curvature of the earth means it's constantly falling just over the horizon. So now you know how objects orbit each other. And yes, there is a region around a black hole where even light is forced to travel in an orbit. This region is called the photon sphere. From far away, black holes may act like any other massive object. If you replace the sun with a black hole of the exactly same mass, our Earth would continue to orbit in the exactly same way. But as you get closer and closer to the black hole, the orbiting mass needs to go faster and faster as it goes around the humongous object. And only light traveling at, well, light speed can exist at this altitude. So that's all for now, folks. See you in the next video.